So let me introduce myself. Myself, Ved Prakash. I'm a PhD scholar in Department of Chemistry, IIT Roorkee, India. So today I'm going to present my poster, which is entitled with the indirect cyanation of beta position in oxidovanadium for tetrabromoporphyrin and its application in biocatalytic activity. So I will start with introductions. As some of us might be knowing that vanadium haloperoxidase is very important enzyme and that is used in that is used as a brominating or chlorinating agent, and we are here to mimic such a enzyme by changing their uh, coordination with a different type of ligand. So here I choose porphyrin, that is tetra nitrogen donating ligand, which binding with the vanadium oxidovanadium with very tight, and the stability of this type of complex are quite high. And also the my main perspective of work is to synthesize tetrabromo and tetracyano based porphyrin, which can be used for the bromination of phenol derivatives. And also this type of catalyst has been noticed to have very high activity for this kind of catalytic reaction. So here is the scheme for the synthesis of tetracyano that I have used. I have synthesized tetrabromo based tetrabromo porphyrin, and directly I have reacted this with the cuprous cyanide in quinoline, and I reflex it for 3 hours, and I got the tetracyano with 32% of yield. So here is the UV. We can see that in case of tetracyano, there is a 4 to 6 nanometer of Soret band is change, and also we are getting Q band at 632 nanometer. So here is the catalytic activity which we are going through. Catalytic activity, and mainly we are focusing on bromination of phenol and phenol derivatives by using the KBr, H2O2 and SClO4 as a reagent in aqueous medium. So here is the EPR spectra of the synthesized compound, uh, the which is showing the two type of G value, which is first one is for the G parallel, and in the middle 8 line is for the G perpendicular, and we can see that clearly 8 line for corresponding to vanadium present in +4 oxidation state. Also, we have recorded the CV for the same compounds. We are getting that in case of tetracyano, the first reduction potential and the first oxidation potential are anodically shifted, which shows that tetracyano is more electron withdrawing group as compared to tetrabromo. And also we have performed the DFT for the same complexes, and we can see that tetracyano has the saddle shape structure having vanadium attached with one oxygen axially. So also we have done the catalytic activity by at the optimized condition, that is 20 millimole of KBr, 20 millimole of H2O2, and 20 millimole of aqueous solution of HClO4 in 20 ml of water. So we have seen that within 15 minutes the conversion of phenols are very good. It's in some cases we are getting around 100%, and in some cases we are getting close to 100%. So that we can also see that the phenol, which is electron donating group, that shows the more reactivity as compared to the phenol, which is which having electron withdrawing group. So we can see that in case of 4-methyl phenol, we are getting 95% of conversion. With in case of using one as a catalyst, and in case of two, we are getting 98% of conversion. Also, in case of 2,4-dimethyl phenol, we are getting 99% of conversion. In case of one, and with the catalyst 2, we are getting 100% of conversion. Also, we can see that we are getting the high value of TOF, that is around 1,55,000 in case of two, and also we are getting 98,000 in case of around 98,000 in case of one. So we can here in the table we can also see that in most of the cases of phenol, we are getting only one product, and that is major one, and in few cases we are getting the mixture of the product. Also, we have seen that these catalysts are showing recyclability, that we have checked with the UV, and also we have checked its mass, that is that we are getting almost similar as the precursor. So UV, there is no change in the show rate and no change in the cuvette, that showing that catalyst is recyclable. Also, the product selectivity, as I told earlier, that in some case, some phenol, we are getting mixture of product. So in that case, we have tried to observe that what is the product selectivity with the time. So here we have taken one example, that is phenol. In case of phenol, we are seeing that earlier at very short of time, that is 15 minutes, we are getting only the monobromo product, that is ortho monobromo and para monobromo, but we are getting very less amount of dibromo product. But as we increasing the time, we are getting the increasing the concentration of dibromo product, and we are decreasing the concentration of monobromo product, which shows that with the time we can observe the product selectivity. Summary, here we have synthesized two, that is tetracyano vanadiol based porphyrin, that is direct cyanation of tetrabromo vanadiol based porphyrin, and in very good yield. Also, we have seen here that these catalysts can be used as a bromination of phenol, and top value in the case of second is very high, and that is highest, I think, till now we have observed. Also, 1 and 2 shows the recyclability, and we have also studied in some cases for the product selectivity with the time. Here are some references that I have followed, and thank you for your attention. If anyone have any question, I will happy to reply.